Before we start anything, let's think about how we can solve this question. In this question, the most awkward part is the numerator value x. Using the definite integral equation, integral 0 to a fx equals integral 0 to a fa minus x, we can remove the numerator value x. After that, to simplify integral 1 over sin x plus cos x value, we can use the theory of the general solution in the trigonometry. Clear? Let's jump into the question. Let's consider the answer to 0 to pi over 2 integral x over sin x plus cos x as capital I. Then we need to find the value of capital I. Then we will keep I equal 0 to pi over 2 integral x over sin x plus cos x as equation number 1. Integral 0 to a fx equals integral 0 to a fa minus x. So instead of function variable x value, we can substitute upper limit minus x. In this case, pi over 2 minus x. So we can rewrite this capital I value as 0 to pi over 2 integral in the numerator pi over 2 minus x over sin pi over 2 minus x plus cos pi over 2 minus x. Sin pi over 2 minus x means sin 90 minus x. Sin 90 minus x equals cos x. Cos pi over 2 minus x means cos 90 minus x. Cos 90 minus x value equals sin x. Then we can write capital I value as 0 to pi over 2 integral pi over 2 minus x over sin x plus cos x. Let's consider integral pi over 2 minus x over sin x plus cos x value as equation number 2. Now we can add both equation number 1 and equation number 2. Then in the left hand side, I plus I. In the right hand side, we have integral x over sin plus cos x plus integral pi over 2 minus x over sin x plus cos x. Then we can consider a common integral sign. Now we have x over sin x plus cos x plus pi over 2 minus x over sin x plus cos x. We can consider a common denominator sin x plus cos x. In the numerator, x plus pi over 2 minus 6. We can cancel out plus x and minus 6. Then we have in the numerator pi over 2. Pi over 2 is a constant value. So we can bring pi over 2 value outside of the integral. After that we have 2y equals pi over 2 integral 1 over sin x plus cos x. Sin x plus cos x value we can write as cos x plus sin x. Coefficient of cos x 1. Coefficient of sin x 1. Then we can get a common factor root 2. Then we can write within bracket cos x 1 over root 2 plus sin x 1 over root 2. First 1 over root 2 value we can consider as sin pi over 4. Second 1 over root 2 value we can consider as cos pi over 4. Then we have expansion of the cos a minus b. So in here we can write cos x minus pi over 4. Simple x value just like capital A, pi over 4 value just like capital B. Let's substitute this value for our integral. Denominator value root 2 is a constant. So we can bring 1 over root 2 value outside of the integral. 1 over cos x minus pi over 4 equals sec x minus pi over 4. Integral sec theta equals ln modulus sec theta plus tan theta. So in here, integral sec x minus pi over 4 value we can write as ln modulus sec x minus pi over 4 plus tan x minus pi over 4. Finally, we can substitute upper limit and lower limit for this answer. First one, upper limit pi over 2. Then we can write ln modulus sec pi over 2 minus pi over 4 plus tan pi over 2 minus pi over 4. Minus, now lower limit 0. Then we can write ln modulus sec 0 minus pi over 4 tan 0 minus pi over 4. We can simplify these values and get the result ln modulus sec pi over 4 plus tan pi over 4 minus ln modulus sec pi over 4 minus tan pi over 4. Sec pi over 4 equals sec 45 degrees. It is equal 1 over cos 45 degrees. Cos 45 degrees equals 1 over root 2. So sec pi over 4 value we can get as root 2. Tan pi over 4 equals tan 45 degrees. It is equal 1. So we can substitute these values for our answer. Then we can write ln modulus root 2 plus 1 minus ln modulus root 2 minus 1. Root 2 plus 1 and root 2 minus are positive values. Therefore, there is no need to write the modulus value. So we can write ln root 2 plus 1 minus ln root 2 minus 1. ln root 2 plus 1 minus ln root 2 minus 1 value we can write as ln root 2 plus 1 over root 2 minus 1. To get rational denominator in the numerator, we can multiply both numerator and denominator value from denominator conjugate. Denominator conjugate equals root 2 plus 1. Then we can get the result in the numerator root 2 plus 1 perfect squared. In the denominator root 2 perfect squared minus 1 squared. Then we can get the result root 2 plus 1 perfect squared. Let's substitute this value for our answer. After that, using basic logarithms rule, we can write 2y equals pi over 2 root 2 times 2 ln root 2 plus 1. After that, we can cancel out numerator value 2 and the denominator value 2. Then finally, we can get I value as pi over 2 root 2 times ln root 2 plus 1.